Okay, in this problem here, we're going to be looking at, it's a projectile problem, and really one dimension, going straight up and straight down to simplify the matters. We get into Cal 1, then we'll talk about how to derive this model up, and we'll be in more than one dimension, but in at least two dimensions. All right, let's see what it says here. A ball is shot from ground level vertically upward with a speed of 100 feet per second. The model that gives the ball's height above ground level is h is equal to negative 16t squared plus 100t. How high is the ball after 2 seconds? How long does it take for the ball to hit the ground? So those are the two questions we want to answer. All right. So I'm just going to go ahead and rewrite this model. H is equal to negative 16 t squared plus 100t. Now, like I said in Cal 1, which I'm sure you're going to take, that will show you how to derive this formula up. And yes, I'm using the feet per second instead of using the metric system, which I'm sure a lot of people are like, hey, why don't you ever use what the rest of the world's using? And I kind of mix it up there a little bit. Okay, try to mix it up. All right. So this is the model that we want to use. Now, let's answer the first question. How high is the ball after 2 seconds? Now, you're probably saying this thing is being thrown upwards, which I should say, it should say, let's see, let's draw, let's say here's ground level, okay? And somewhere in the ground, we got a cavity somewhere in the ground. Makes all kinds of sense, doesn't it? We'll let the ball be here. Our projectile will be there. It's being launched from ground level, right? So we'll pretend a gopher's throwing a rock out of his hole, straight upward. I don't know. Right, so it's going straight up. We'll use a different color. It's going straight, and when I mean straight, I mean straight. All right, that's not a straight line, but you know what I mean. It's going straight up, and then it's coming straight back down again. That's what I mean by one dimension. It's going straight up and coming straight back down. So you understand what I mean. All right. Okay. This question here, how high is the ball after 2 seconds? So if all we have to do here is just plug 2 in. So the height is equal to negative 16 times 2 squared plus 100 times 2. All right, that's all we got to do in this problem. And what do we get here? 16 times, we get negative 16 times 4 plus 200, right? And I'm getting 136. And of course, that's going to be in feet. 136 feet. Huh. Yeah. Negative 16 times 2 squared plus 100 times 2. 136 feet. You know, my question is how high did the ball go? That's the question, or the rock, or whatever you want to call it. Yeah, how high? How high did it go? That's something you need to work on. Okay. All right. What's the next question here? Seems like I got a different number last time I did this problem, but I'm pretty sure I got that right. Negative 16 times 4 plus 100 times 2 is 136. Okay. I don't want to make any mistakes. How long does it take for the ball to hit the ground? In other words, it went all the way up, and then it came all the way back down. How much time did that take? What does that mean? That means when the height is 0. Well, the only 2 times the height is 0 is when time is 0. Before it even left the hole. That's one time, and the other one we're trying to figure out. All right. So let's go ahead. Is that what the problem is? Hold on. No, it's negative 16. Okay. T squared plus 100 t. So we're setting the height equal to 0, and we're solving for t in this problem. Okay. What are we going to do? Well, what did I say here? We need to always have a positive, first off, that coefficient. So we need to make sure we factor out that negative, okay? We're factoring out a -1. What else can we factor out? There's some other things we can factor out of that, because 16 and 100 are both even numbers, so you know we're going to probably be able to factor a 2 out of there. But at this point, let's just factor -1 out. Now we can also factor what else out? There's a t, 2 t's and 1 t here. Okay, 2 t's and 1 t, so we can factor a t out. So let's just do that. Okay, let's just factor that negative t out. So we're going to be left with 16t, and we could factor some other, we know we could factor 2 out. We know that for sure. But let's just go ahead and not do that. Okay, so here's our 2 factors. We're going to set them both equal to 0. So we have negative t. We'll set that factor equal to 0. And then we'll set the 16t plus 100. We'll set that equal to 0. And then we'll solve for t in both of these. So in this one here, this is easy. Just multiply both sides by -1. You get t is equal to 0. Well, I said that, right? When the height is 0, well, one of them for sure is t is 0. Okay. Now this one over here on the right-hand side, all right, let's move that 100 over to the right. Becomes a -100. And then we'll multiply both sides by 1/16. So that leaves us with t is equal to negative. What? Something's not right. Oh my gosh. Let's go back up here for a second. You were probably screaming at me, I'm sure. When we factor that negative out, that's going to make that a minus sign right there. Okay, I failed to see that. See, even after doing math for 100 years, you still make mistakes. I knew that when we had a negative time there, something was not right. Yep. Okay, as long as it gets corrected. Then multiply both sides by 1/16, so we have 100/16, which reduces down to, but what I'm going to write this in, we'll just write this in a decimal form, and we might even approximate it, I'm not sure. So what's 100/16? Write that as a decimal. Okay, it's a nice number. Nicer than I thought. 6.25. And of course, don't remember, it's in seconds. I don't want to forget that. Okay. 6.25 seconds. So that's how long it took for the projectile, or the ball, we're saying. Yeah, I know. The ball rolled into a rabbit hole. That's what it was. And the rabbit turned around and kicked it with its two back feet straight up in the air, and it came back down in the hole. Rabbit wasn't happy. All right. So it went up. Do you like my stories? It went up, came back down. What comes up must go back down. And it took 6.25 seconds. We'll just write it right here. Now, because this is symmetric, we can kind of figure out how long it took for it to reach a maximum height. I'll let you figure that out because it's symmetric, right? We have symmetry involved here. And then once we figure that out, we can figure out what its maximum height was, all right? I'll let you work on that. Well, we're already at 11 minutes. Okay, we finished this problem. Spent way too much time on it. All right, see you over there. Bye.